All right, let's talk about one of the most incredible events we have ever witnessed in the cosmos. I'm talking about a head-on collision between two massive galaxy clusters. It's an event we call the bullet cluster, and for a long time, it's been seen as the ultimate proof for dark matter. But it might also be the key to unlocking a totally new way of thinking about gravity, space, and everything in between.
So, what's the big mystery here? Well, it really all comes down to one simple nagging question. When we point our telescopes at the bullet cluster, we see all the normal stuff, the stars and the gas. But when we measure where the gravity is, well, most of it seems to be coming from nowhere. There's this huge gravitational pull, but we can't see what's actually causing it.
So here's how we're going to break this down. Think of it like a cosmic contest, a real showdown of ideas. First, we'll investigate the crime scene. Then we'll bring in the main suspect, dark matter. After that, we'll let two challengers enter the ring. The famous theory of modified gravity, and then a really wild new idea about the vacuum of space. Finally, we'll run the numbers and see who actually wins.
Okay, let's get to it. We're heading straight to the cosmic crime scene. What we're looking at is the aftermath of two galaxy clusters that absolutely slammed into each other at a mind-boggling 4,000 kilometers a second.
The evidence here is just wild. That pink stuff you see? That's superheated gas, and it makes up about 90% of all the normal matter in these clusters, what physicists call baryonic matter. Now, because gas can smash into itself, it got all tangled up and stuck right in the middle. But the galaxies themselves, they're mostly empty space, so they just passed right through each other like ghosts. And here's the real kicker. The gravity, which we've mapped here in blue, it didn't stay with the gas. Nope, it went right along with the galaxies. So the stuff is in one place, but the gravity is somewhere else entirely.
So you've got this complete separation of stuff and gravity. How on earth do you explain that? Well, let's start with the reigning champion, the standard explanation, dark matter.
The standard model of cosmology, what's called lambda CDM, has a really neat solution for this. It says that each of these galaxy clusters is sitting inside a giant, invisible halo of dark matter. And crucially, just like the galaxies, this dark matter is collisionless. Its particles don't really interact with each other. So when the clusters collided, these huge dark matter halos just sailed right on through, taking all their gravity with them and leaving that poor gas cloud behind. Problem solved, right?
Okay, that's the standard story. But what if there is no mysterious missing substance? Let's bring in our first challenger. This one suggests we don't need dark matter at all. Instead, maybe the laws of gravity just aren't what we think they are.
This idea is called Modified Newtonian Dynamics, or MOND for short. And for decades, MOND has been a real powerhouse. It's been incredibly good at explaining why galaxies don't just fly apart, why their outer stars move so fast. It does this by tweaking gravity, making it a little stronger in places with really low acceleration. And if MOND is right, you don't need dark matter at all.
But, and this is a huge but, the bullet cluster is MOND's kryptonite. See, the whole point of MOND is that gravity is always tied directly to the normal matter you can see. And in the bullet cluster, most of that normal matter is in that gas cloud in the middle. So MOND predicts the center of gravity should be right there with the gas. It just has no way to explain why the gravity is offset by 250 kiloparsecs. And for a long time, this has been seen as a fatal blow to the theory.
So the standard model needs a mysterious, unseen particle, and MOND just can't seem to make it work. This is where a truly wild, mind-bending new idea steps onto the scene. It's called dynamic vacuum field theory, or DVFT.
Okay, that sounds super complicated, but the core idea is actually pretty incredible. DVFT says that what we call empty space isn't empty at all. It's a real physical thing, a dynamic medium. And when you put normal matter into this medium, it creates ripples, or perturbations. And those perturbations can create their own gravity.
So, according to this theory, these distortions in the vacuum act like a kind of collisionless superfluid. Think about it. During the bullet cluster crash, the gas particles all smashed into each other and slowed down. But these vacuum perturbations, carrying all this gravitational energy, they would have just passed right through, sticking with the galaxies that created them. This could totally explain that weird offset we see.
Now don't let the math here scare you off. We're not going to solve this thing. But I want you to look at the rulebook that describes this vacuum field. The really important part is that nonlinear term right there. That little x to the power of 3/2, that's the engine. That's the part of the math that allows the vacuum's gravitational effect to get massively amplified, especially in a low acceleration place like a galaxy cluster.
It's a fantastic story, right?
But in physics, a cool story isn't enough. You have to back it up with numbers. The real question is, does this rulebook for the vacuum actually predict the right amount of gravity in the right place? Well, let's run the numbers and find out.
And the test is actually pretty straightforward. It's a three-step process. First, you take the mass of all the stuff you can actually see, the galaxies. Second, you use that DVFT rulebook to figure out how much effective mass is being generated by the disturbance in the vacuum. And third, you just add them up to get your final prediction.
Okay, step 1. We start with what we can see. The total visible mass of the galaxies in that smaller cluster comes out to about 3.1 trillion times the mass of our Sun.
Now for step 2. We take that visible mass and we plug it into the DVFT equation, and what comes out is just staggering. The theory calculates an effective mass from the vacuum itself of 197 trillion solar masses. That's over 60 times more gravity than the visible matter can explain, all supposedly coming from empty space.
All right, this is it, the moment of truth. We have the mass of the galaxies, and we have the calculated mass from the vacuum. Let's add them up and put this radical theory to the ultimate test against what astronomers have actually observed.
And look at that. Just look, the DVFT prediction, when you add the galaxy mass and the vacuum mass, comes out to 2.0 times 10 to the 14 solar masses. And what did astronomers actually measure using gravitational lensing? 2.0 plus or minus 0.2 times 10 to the 14 solar masses. It's a perfect match. The prediction from the theory lines up almost exactly with the real-world observation.
So what's the big takeaway here? Well, this theory seems to solve both of the bullet cluster's big problems in one elegant swoop. First, it creates all that missing gravity without having to invent any new particles. It just sources the energy from the vacuum. And second, because these vacuum distortions are collisionless, it perfectly explains why there's that 250 kiloparsec gap between the gas and the center of gravity.
This leaves us with an absolutely provocative final thought. For decades, we have been hunting for a mysterious, invisible particle to explain the missing gravity of the universe. But what if the answer isn't a particle at all? What if the phenomenon we call dark matter is really just the energy of empty space made visible by the presence of matter? It's a radical idea for sure. But in this cosmic crime scene, it's an idea that fits the evidence with stunning precision.